All right, so we're on SIG 14. Congrats, you only have a little bit farther to go, a few more SIG tests to pass. The first question here is another written response one. We want to describe with some detail, oh gosh, not in detail, don't erase it, in detail, the process to find the relative extrema of a function. Okay, so remember, if I have a function like this, the relative extrema are these little peaks and valleys, right? This would be a relative min. Some people call it local min. This one is also a relative min, and this one here is a relative max. Okay, these are not absolute maxes, they're relative. The way we know they're relative is the slope at that point is 0. There's a horizontal tangent line there. And knowing that is how you do it, right? So what do you do? Well, you take the derivative, find critical values, and then determine there's actually two possible things we could do here. So let's do this. So once we're here, there's two ways we could go. The first way is use the first derivative test, which means you make a line like this. Let me write this in words. Check the behavior on the left and right. And if we notice that if it goes from increasing to decreasing, right, that's like this, that means there is a relative max. If it goes from decreasing to increasing, like this, that means there's a relative minimum. Okay, the second way we could do this at this point is we could take the second derivative at the critical values, right? If there's two critical values, then we plug in the second derivative. If we get a positive number, that means the function is concave up at that point, which means we have a relative minimum. If it's negative, then we have concave down, which means it's going to be a relative maximum on that point, right? So this is the second derivative test for max and min. Okay, part 2 is describe in detail the process to find the absolute extrema of a function over a closed interval. So what this means is we're given some interval, call it like AB, right? Let's say A is here and B is here, and we have some function that maybe goes like this, right? And we're asked to find, let me draw it slightly differently just to make it easier. We're asked to find the absolute maximum. So that's like the highest point on the graph, right? And so in this case, the absolute max is at x equal b, right? And the absolute min in this case is at x equals a, right? And so, but we could have had a case maybe like this, where the absolute max would have been somewhere in between a and b, right? So what you have to do here is, one, you have to find critical values. Let's write this. Let's find candidates. We're going to call them candidates, right? Where candidates are critical values and endpoints, right? What are we going to do? Well, all we want to know, like, so critical values are where you might get a point like this, right? And endpoints are the situation right here where they might be the absolute max. So all we need to know is like what's the biggest and what's the smallest. So what we're going to do is we're going to plug candidates into the original function, right? So what I suggest is you make like a little table of values, and you're going to put your x values here and your f of x values here, right? You're going to plug in a, you're going to plug in any critical values you have, and you're going to plug in b, and you're going to get, you know, some numbers over here. And whichever one is the biggest is the absolute max, whichever one is smallest is the absolute min, right? So what I'm looking for on this question is this part here. You need to know that. And what I'm looking for on this part is, one of these two things, either that one or, not just copying it exactly. You can describe in your own words if you want. And then that one. Okay, so let's actually do this. Part 3, or question 3, is we want to find the absolute minima and absolute maxima on the given interval. So remember, what we're looking for are candidates. 2 of the candidates are given to us, right? One candidate is x equals 0, one candidate is x equals 2, and the other candidate is going to be any critical value, right? Which we can find critical values by taking the derivative of our function, which in this case the derivative is 4x, setting it equal to 0, right? We're finding critical values, and we're going to get x equals 0. So that gives me this one again. So I don't need to write it twice. Those are my candidates. So we're going to make a little table of values. We're going to put x, y. We're going to plug in 0 and 2. If I plug in 0, I have 0 squared times 2 minus 1, which is negative 1. If I plug in 2, then I have 2 squared, which is 4, times 2 is 8, minus 1 is 7. So because this is the biggest, because this is the smallest, the absolute min occurs at x equals 0 and has a value of, a minimum value of y equals negative 1, because they will differentiate with that between that sometimes. Okay, here this is the biggest number, so the absolute max occurs at x equals 2 and has a max value of, has a value of y equals 7. Right, again, this is the maximum value. This is where the maximum value occurs, right? It's a matter of where versus what. Okay, next one, we want to find all relative minima and maxima. So this is that first question. How do I find relative minima and maxima? I find the critical values, and I do like a sign chart, or I do the second derivative. So I'm going to do this 2 different ways. Keep in mind you don't have to do it both ways, so this may seem longer than it has to be. In either case, I need to take the first derivative, which may require some chain rule. What I'm going to do is I'm going to move this negative up here, right? Because it's just weird having it in the middle there. So using quotient rule here, it's going to be the derivative of the top, which is just 0. So it's going to be 0 times something minus the derivative of the bottom, which is 2s times negative 3 all over s squared minus 9 squared. Let's clean it up. It's going to be 6s over s squared minus 9 squared. The critical values when this equals 0 are going to be when s equals 0, right? You set the top equal to 0. Let me just write that out just so we don't mess people up. 6s equals 0, divide both sides by 6, you're going to get s equals 0. Right, I set the top equal to 0. I also just set the bottom equal to 0. You square root both sides, you get s squared equals 9. So s is going to equal positive or negative 3, right, if you take the square root of both sides. So our critical points are 0, negative 3, positive 3, right? And we need to check the left and the right. This is if we're doing the first derivative test. We're doing it this way, right? So I need to check a number just left of negative 3, which is like negative 4. Keep in mind when you're plugging it into the first derivative, the denominator is always going to be positive, because when you square something, it's always positive. So if I do 6 times, let's say we're choosing negative 4 over here to plug in. 6 times negative 4 is negative, which means this function's decreasing right here. If I plug in negative 2, it's still negative. If I plug in a positive number, it's going to be positive, positive. So the only relative extrema occurs at x equals 0. It's a relative minima, right? Because it went from decreasing to increasing. So there's a relative min at x equals 0. We do want to find the y coordinate as well, which means you just take 0 and you plug it into your original function. Hello. What's up? Sorry about that. Student just walked in. So we're taking 0, we're plugging into the original. It's going to be negative 3 over negative 9, so the y value here is 1/3. There is no relative max on this particular problem. Okay, let's just, so that you're done. If you wanted to do the second derivative test, what you would do, sometimes it's easier, sometimes it's not, is we would take the second derivative, which in this case is not very nice. Sometimes it is. So we're going to take 6 times, so it's the derivative of the top times the bottom, which is s squared minus 9 squared. We're going to subtract by the derivative of the bottom times 2s, that's the inside, all over s squared minus 9 squared. And we're going to plug in our critical value there. So we're going to plug in 0 because we want to know if there's a max or min at 0. So we're plugging in 0 everywhere we see an s. Basically, this whole thing is going to turn into 0. This side is going to turn into negative 9 squared, which is 81, positive 81 times 6 on the top. And on the bottom, it doesn't matter what we plug in, it's going to be positive. So all that matters is we're getting a positive number, which means our function is concave up, right? If the second derivative is positive, it's concave up, which means that point must be a relative minimum because it has to look like this, right? So that's the second derivative test, is you take the second derivative and you plug in your critical values and you'll get positive or negative. Positive means minimum, negative means maximum. All right, so good luck.